So we'll take a look at the architecture, and then we'll move on into a demonstration. So Rich, introduced the product. He talked about some of the components and the technologies. So I'll take you through our core architecture. In this first section, I'm going to do it essentially in the order that would be deployed, and then we'll take a look at how the different options for recovery, and then ultimately we'll get into a demo. So with the diagram we've got here on the left-hand side, this is a protected site. So this could be an on-premises data center, or this could be a co-location facility, or this could actually be another cloud. For our purposes and to line up with the demo, this is an on-premises site. So we'll see here, there's a VMware deployment, vCenter, the ESXi hosts, and the like. So the first component for us is our management server appliance. It's a lightweight Linux virtual machine. It integrates with vCenter. It's the focus for us for the orchestration and the operation of our software. So as far as the deployment process, you download our software bundle. The key portion of that is the virtual appliance, the OVA for the management server. You deploy that management server OVA, you bring it up, you register it with vCenter. Once it's registered, we have a plugin, just a regular vSphere client plugin. So if you're a VMware administrator, you're going to find our UI right there in the client. It'll be comfortable to use, and you'll see it in the demo. One point I do want to make here is that everything we do with our plugin actually uses our API. So the management server was created, this management operations set, with a set of APIs for automation, for integration. So while I'll demonstrate this stuff using the UI, all of this can be scripted, or all of this can be run through, an IT system management system or the like. So the next component, and Rich mentioned this already, is the IO filters. So is everyone familiar with how IO filters operates, or are there any questions about what we get from IO filters?
Just another side question, just to confirm, is the demo that you're showing just vCenter only, or is it just the product in general is specific to ESXi?
So the product is specific to VMware.
VMware, okay.
So it's a VMware environment being protected to another VMware environment, or being recovered into another VMware environment.
Got it, okay.
All right, so with the IO filters, the next step, so we've registered the management server, we're in the UI, we want to go configure the cluster. When we configure the cluster, that installs our IO filter package onto the ESX hosts. Once the IO filters are in place, that'll give us the ability to, as Rich already mentioned, we'll get a direct tap of the storage traffic coming from the virtual machine through the hypervisor to the storage system. The next component for us is our DR virtual appliance. So the DR virtual appliance, this is another lightweight Linux appliance. This is actually deployed via the UI or via the automation. So Linux appliance, this component takes the data stream coming from the IO filters on ESX hosts, processes it, and then creates the objects that are then replicated out to the object store. So we've got, continuous replication. The DRVAs, there's a minimum here, 1 per cluster, but we can scale out the number of DRVAs based on the number of machines that are protected, the number of protected domains. For our terminology, a protected domain is the group for the virtual machines that are being protected. We protect a protected domain, we fail over a protected domain. So a virtual machine, once it's been, when we add it to protection, is a member of that protected domain. So the next piece is the object storage. So in this case, we're talking about an Azure storage account in the demo. It can be any S3 compatible storage or Azure storage account. So in the diagram here, again, I've got the protected site on the left, and then I've got this storage site. Now, typically, this object store is going to be located near the recovery site. For our purposes, it really is, it's independent of either the protected site or the recovery site. So once a virtual machine is protected, so it's been added to a protected domain, the initial replication, the initial synchronization has completed, then that virtual machine is protected. And by that, we mean not only has the data been written to the object store, but also the configuration for that virtual machine. And actually, we have the status information for the protected domain. We have all the configuration information and other settings that we would configure with the protected domain, including the runbook groups, and that's all contained in the object storage. So at the point where the machine becomes recoverable, we can actually lose everything at the protected site and recover all the protected virtual machines out of this object store. All right, so we'll go on. Rich mentioned that we had the a near zero RTO option, or we have an on-demand recovery, for a longer RTO. I'll start with what we call a standard recovery or a standard failover, and then I'll move over to the continuous. So for the standard failover, we've got our protected site, right? The software is installed, the virtual machines have been protected, they've been added to protected domains, the runbooks have been configured and the like, and everything's being replicated into the object store. So for workloads that have an RTO, right? We've got enough time in this RTO, enough time to be able to bring these things back up and get them running to include the provisioning of the recovery site. You wouldn't have to have the recovery site up and running to begin with. So we don't have to have compute and storage there. Now, in our demo here, we'll see that we've got a combination of this, and that's what we expect with most customers, that there's a combination. Some of the virtual machines, some of the protected domains need a much lower RTO. Certainly wouldn't include the amount of time it would take to, for the example here, to stand up a new Azure VMware Solution private cloud and get it configured. But for the sake of explanation, we'll talk about this standard failover, and then we'll show you the other. So again, data is being replicated into the object store. It's being kept up to date. Then we have a disaster event. So now the protected site is no longer available, or a significant portion, or the network connections is broken, whatever happens to be the issue. So then for this more economical version, we would stand up the recovery site. Now, for the sake of argument here, this is a Azure VMware Solution private cloud, or it could be another site. So we've got the VMware environment in place. Then we deploy our software. With Azure VMware Solution, we have integration with the Azure team. We've worked with them closely. So any Azure VMware Solution private cloud that's deployed already has a set of PowerShell commandlets available under the run command for the lifecycle of JetStream DR. So in the case here, if that recovery site is to AVS, rather than go through the manual installation steps that I described initially, go to the run command, you would tell it to install JetStream DR, you'll fill in the form, and then it will automate the process. Now, part of that's for convenience, and part of that is because, in this provider environment, in the Azure VMware Solution, the customer has the cloud admin user, not the full-featured administrator that they might be used to from vCenter. So we take care of the elevated privilege. User accounts created just for the duration of the installation. The management service deployed, it's registered with vCenter. The clusters are configured, so the IO filter driver is added to each of the hosts. And then the next step for us would be to deploy DRVA. Now, the DRVA configuration here, we would want it to be similar to what was on the protected site.
Anthony,
And
can you hear me?
you have a question?
Yeah. So I just want to go back to the part where you created this recovery site on demand. Who's doing that and where and how?
So that's up to the customer, right? For the example here, it's going to be an AVS private cloud. So we don't orchestrate the building of the recovery site. We don't orchestrate the configuration of the recovery site. We would just need to be deployed at the recovery site prior to performing a failover.
It's just that the way you advertise it, the way you described it was like for cost savings reasons, we're not going to configure the DR site until we need it. So I was just trying to understand, what a customer would have to do to prepare the site. So it just sounds like they're responsible for creating this site. Are they also responsible for creating the VMs into which you're going to be restoring, or is that part of what you do?
So are you talking about the VMs that we would be recovering from the primary site?
Yes.
So now we will orchestrate the recovery of those machines. We'll bring them over, we'll stand them up, we'll power them on. That's all part of the product.
Okay. So what they're essentially configuring is a shell of an account with your, and into which they're installing your software.
There'd need to be an environment where the recovered virtual machines would be able to operate after they've been failed over. Right. So it's maybe a bit more than a shell, right? So if we're talking about the Azure VMware solution, they'll need to deploy an AVS private cloud. So that's a VMware environment hosted in a Microsoft data center. It's got its own network configuration and like, so that all would need to be put into place. And then you would add the JetStream DR software to that, and then we could recover the protected virtual machines that are in the object store. We could rehydrate them out of the object store and then bring them up.
What I'm hearing from this is that I feel like I'm in therapy. So what I'm hearing you say,
Yeah.
we would already have to have a live. You assume that we have a live VMware vCenter environment, so that the stuff's there to receive the object registration. Versus, I think, Curtis, you're saying, I'm assuming you got nothing. I'm just firing the stuff.
Well, he made the point.
Right.
Sorry to cut you off.
Yeah, no.
He made the point that we're not going to do this until recovery.
Right.
So I just want to know what that would be, right?
Yeah. So the point about the not needing the compute resources on the recovery site until after the disaster, that's baked into the product, right? We don't replicate to another live system. It's not one-for-one replication. You protect the virtual machines. We have the data and the configuration. That's actually stored in the Azure storage account in this case. So that's in the object store. So there's no requirement for protecting those virtual machines to have a running site on the recovery side. Now, of course, you may have other operational things that say you have a running site on the operational side. And in the next example, where we want to have that lower RTO, we'll definitely say you have that site. It's up, it's running, it's configured, it's ready to take those workloads. So for the purposes of this mode versus the next, it's a matter of when is the other site required? I guess that's the way to put it for this.
Yeah, the one thing I guess I could pull from what I believe you're heading towards is if you're going to a near zero RPO, and I don't even think that you can just like spin up AVS. I think you actually need your account to light it up. You're talking like 24 to 72 hours if you got your account rep's phone number. Like, I don't think you can just spin up a brand new AVS.
If you have an Azure subscription, you can.
Is it?
Boop it.
It's not like, okay, so it's not like
What?
CNAWS.
You can just boop it.
Boop it?
I
You can
didn't know
boop
it was
it.
Okay.
What Ned meant was write a Terraform, deploy it with using Terraform.
Like I said,
That's it. That's what we, okay.
Yeah.
Because
EMC and AWS is not boopable.
it's
It requires you calling a person to do the booping for you.
getting away from Azure for a second. Well, actually, my question would be that object storage that's specified in the storage site, does that have to be Azure storage, or is that any object storage? Target, S3, Google object, I don't know.
Like a Minio or whatever you got.
Yeah, Mini.io,
So-
whatever it is.
Amazon S3, Minio, S3 compatible, or an Azure storage account, or what we're talking about here.
Okay.
So I'll continue on with this. This is not the near zero RTO. This would be we have plenty of time to stand up the environment, and then we'll get to the near zero RTO. So once we have the JetStream installed on that recovery side, and we have the DRVA configured, the next step for us would be to connect to the storage site, import the domains that we're interested in, and then start that the failover. A point that I want to make before we get too far with this, and it's maybe related to this idea about what's required on the recovery site prior to the failover and what's required after. This installation that we've just been performed on the recovery site is completely independent of the JetStream installation on the primary site. So, in other words, we don't have any connection between the management server on the protected site with the vCenter on the recovery site, or to any other component on the recovery site. All of our protection is focused on that object store to make it so that you could recover, on demand to another place without requiring that. So what we'll see here, when we start a failover, we need to transfer the ownership of that protected domain from the JetStream installation on the protected side to the JetStream installation on the recovery side. Now, that's there. We call the feature IO fencing. That's there to make sure that while the virtual machines are protected, only one site can update the configuration, only one site can update the data. Other sites can be connected, and what we'll see in the next example, we can actually be rehydrating the data out of that object store while they're still being protected on the recovery side to one or more other location, but only one site can make the update, so we transfer the ownership. So we'll start the process, we'll transfer that ownership, and then we'll start the failover. So this normal standard failover is done on demand. So what we'll see in this case, you've gone to the vSphere client on the recovery side, you've gone to our UI, you've selected the protected domain you're interested in, and you start a failover. As you go through the process of starting the failover, we're going to prompt for the DR virtual appliances. So I described it before. Again, the DRVA is responsible for taking the data stream or running virtual machines and replicating it to the object store. We require those to be configured on the recovery site because as soon as we finish the recovery of the virtual machines, as soon as the failover is there and the virtual machines have been powered on according to the runbook, we immediately resume protection. So in the diagram, you'll see that another item's popped up. We've got this recovery virtual appliance. We call it a ROC VA in some cases. So for the duration of the recovery, one per protected domain, this recovery virtual appliance is deployed. It's responsible for reading the data out of the object store and rehydrating the virtual disks for the VMs being recovered. So there's no shadow VM. There's nothing like that there that exists on the recovery side until we start this process. And then there's a little, we call it a receiver VM or a recovery VM. It's basically there to present the virtual disks that are being rehydrated. The recover appliance makes an iSCSI connection to these VMs, rehydrates the disks, and when the rehydration is complete, then we will power on the virtual machines according to the configuration in the runbook and according to the order and the like of the runbook, and then they'll come up. So this idea of the no ongoing compute, again, if the RTO, so if this amount of time we've got to restore these virtual machines is long enough that you didn't have to have an existing environment, you could deploy that environment, install our software, and then perform the failover. We support the virtual machines, the virtual guests, if they were configured with static IP addresses, they'll be recovered with the same static IP addresses. If you need different static IP addresses for those virtual machines, that can be configured in a runbook on our protected domain. And I'll show this to you in the demo. The runbook is part of the properties for that protected domain. We actually have 3 possible runbooks for a protected domain: a failover runbook for the operation we're talking about here, a test failover runbook, so for a test failover operation, or a failback runbook. They're all configured, they're all properties of that protected domain. We have an option for a planned failover. So in the case where there wasn't a disaster, but really what we want to do is take advantage of resources in another site. We want to distribute those workloads. We could actually orchestrate this. It's essentially a migration. We could orchestrate the recovery of a protected domain into another site. So we'll finish the failover. The machines come up, they're protected. We immediately resume replication. So to the same exact container inside that object store, it's being kept up to date. And should we plan to fail back or recover whatever needed to be recovered, remediate whatever on the protected site, then we'll initiate a failback. Now, in the case of a failback, both sides are up and running. So we'll start the rehydration. When we start the failback operation, the VMs will continue to run on the recovery site. They'll continue to be, the DRVA there will continue to update the object store. And when we get to an interval that's configured by the administrator where the replication is almost complete, then we'll gracefully shut down the virtual machines on the protected site, finish the replication, and then again, bring up the virtual machines according to the runbook configuration, and they would be returned back to operation at the recovery site. We would or the protected site, and we just resume protection. So that's one mode. So that's this, we call it standard failover. So so
Anthony, so what kind of recovery time should I expect for restoring this data from the object storage into the recovery site?
We expect about 6 terabytes an hour is the rehydration rate. So whatever the protected data set for that protected domain, we can do the math. It's about 6 terabytes an hour for rehydration.
Regardless of the size of the environment. So is that 6 terabytes an hour for the entire environment or 6 terabytes an hour per VM?
6 terabytes an hour for the protected domain. So whether that's per VM or per the whole protected domain, that's the rate we expect the rehydration to run. Ultimately, all of the virtual machines in the protected domain have to be rehydrated before we power them on. So we'll call that per protected domain. That's our unit for protection. That's our unit for failover.
So you're basically doing 1 VM at a time, and that's the rate at which.
So we're rehydrating more than 1 VM at a time, but the whole protected domain will have to be complete before we power on the virtual machines.
Yeah, I'm just trying to understand why it would be limited to 6 terabytes an hour.
And so
Like if you've got 1,000 VMs, and you're in the cloud, you have 1,000 VMs, you have unlimited resource with the object storage, you have unlimited resource in the recovery site. Why can't you do 1,000 VMs at one time, and why would that then be limited at 6 terabytes an hour? That's
So
what
the
I'm
example, so what we're talking about, it's the connection between the object storage itself and that VMware environment that we're recovering into.
But it's not throttled.
Yeah, it is. You're limited to like 200 megasecond storage.
Yeah. It's going to be limited
Maybe
to
in
whatever
Azure.
the gateway is or the network connection is between that VMware environment and the object storage.
Okay.
So you get one more round of this. I'll show you this, the near zero RTO option. So similar environment that we had before. Now, the biggest difference, back to the original question, in this case, you would already have the environment up and running on the protected site. So there's already a VMware deployment there. The JetStream software is already installed. The virtual machines are running at the protected site. They're being replicated into the object storage. The key difference here is rather than waiting for the disaster event to occur, we'll start this rehydration well in advance. So you could start this as soon as the virtual machines were recoverable from the protected side, right? The initial synchronization has completed. We can start this, we call it continuous failover. So in this case, we'll start that rehydration. Now, with the diagram we've got in front of us right now, this is just the sort of steady state for their protected. The virtual machines run on the protected site, the object store is updated, and then the recover appliance is updating the virtual disk for the protected machines. So the key thing here is, if we're talking about that 6 terabyte an hour rate, we're not waiting for that for this final cutover. So now, same scenario, we have our disaster. So we lose the protected site, we lose the connection, whatever it turns out to be. So now we're going to recover out of the storage site. So we'll transfer ownership, again, same as before. But what we'll find in this case, and I'll show this to you in the demo, since we've been already rehydrating the data into the primary storage on the recovery site, and for that purposes, that could be being rehydrated into any data store that's presented by VMware we can rehydrate into. In the demo, you'll see, since we're using the Azure VMware solution, we're going to be rehydrating some of the virtual machines to a vSAN data store, and we'll be rehydrating other virtual machines into ANF back data stores. So in any case, we want to complete the failover. So in that case, we'll transfer the ownership. That takes us about 5 to 6 minutes. It's essentially, we're checking to see if the JetStream system on the primary site is still updating. Is it still, keeping a heartbeat? If it isn't, then we'll go ahead and take over. If it is, we can force it. We'll transfer ownership, and then we'll complete the rehydration. And then, as before, the virtual machines are protected and they continue on. The key thing here is, regardless of the amount of protected data, the RTO in this case is really driven by the amount of time it takes to transfer the ownership. So in the demo, you'll see that it's about 5 to 6 minutes. And again, now the key difference here is we're not waiting for all of that rehydration to happen. Most of it's happened already. We just have the final sync interval to take over. So then, as before, the machines are protected, and if you wanted to fail back, we'll recover. Same thing, live failback. And if you had the domain configured for this continuous rehydration, once the machines were up and running, it would just be resumed, and we'd back to where we were before.
What do you have as far as what do you have for in-guest reconfiguration at the target? Because stuff like IP address reconfiguration, any other localized scripts, are there options to run post-recovery scripts and such? And you may take this into the demo. I apologize if I'm holding you at a slide to try and explain this.
So I can show it in the demo. There is.
Right.
So within the protected domain, there's the runbook. Within the runbook is where we would configure if the virtual machine needed to change the IP address. That's a per NIC configuration in there. There's an option for running a script at the beginning of the failover operation. There's an option for running a script at the end of the failover operation. And there also could be a script running per virtual machine during the operation.